Welcome to Stress-Free Coding Channel, HTTP Part 3. I'm stoked, so let's start right away. Today I will talk to you about these topics: browser cache, shared cache, headers for cache control, outdated JavaScript and CSS file. The HTTP cache stores a response associated with a request and reuses the stored response for subsequent requests. HTTP is a protocol designed to cache as much as possible, so we don't specify cache control in our code. Responses will get stored and reused if certain conditions are met. There are two main reasons that web caches are used. First, to reduce latency. Because the request is satisfied from a cache instead of the origin server, it takes less time for it to get representation displayed. This makes the web seems more responsive. 2. To reduce network traffic. Because representations are reused, it reduces the amount of bandwidth used by a client. A private cache is a cache tied to a specific client, typically a browser cache. If you examine the preference dialog of any modern web browser, you probably notice a cache settings. This lets you set aside a section of your computer hard disk to store representation that you have seen just for you. The browser cache works according to fairly simple rules. Cookies are part of a browser cache. This cache is especially useful when we hit the back button or click a link to see a web page that we just looked at. Also, if we use the same navigation images throughout our site, they'll be served from browsers' caches almost instantaneously. The shared cache is located between the client and the server and can store responses that can be shared among users. Shared caches can be classified into managed cache and proxy cache. Managed cache is deployed by service developers to offload the origin service and deliver content efficiently. Examples include the reverse proxies, CDN, and service workers in combination with Cache API. Web proxy caches work on the same principle but at some larger scale. Some proxies implement caching to reduce traffic out of a network. This is usually not managed by the service developer, so it must be controlled by appropriate HTTP header and so on. However, HTTPS has become more common in client-server communication has become encrypted. Proxy caches in the path can only channel a response and can behave as a cache. A way to define when the cache is stale is to set a sort of shelf life. Until HTTP 1.0, this was possible by expires header. The expires header using explicit time rather than by specifying an elapsed time. However, the time format is difficult to parse, many implementation bugs were found, and it is possible to induce problems by intentionally shifting the system clock. Therefore, from HTTP 1.1 MaxAge was adopted for cache control. Instead, for expires, MaxAge header specifies an elapsed time. So, MaxAge header is defined to be preferred compared to expires header. The value of eTag response header is an arbitrary value generated by the server. There are no restrictions on how the server must generate the value, so the server are free to set the value based on whatever means they choose, such as a hash of a body, contents, or a vector number. As an example, if a hash value is used for eTag header and the hash value of an HTML page resource as an image, that response is stale, the client takes the value of the eTag response header for the cached response and puts it into the if known match request header to ask the server if a resource has been modified. The server will return 304 not modify if the value of a tag header is determined for the request resource is the same as the if non-match value in a request. But if the server determines the requested resource should now have a different tag value, the server will instead respond with, if we don't want a response to be reused, but instead want to always fetch the latest content from the server, we can use the no-cache directive to force validation. The no-cache directive doesn't prevent the client store responses, but instead prevents the reuse of response without the revalidation. If we want to be sure that an absolute response containing a proxy cache is not provided to the client, we can specify private as well as a no-cache. Instead, if we don't want a response stored in any cache, use no-store either. The no-store directive prevents a response from being stored by the client, but doesn't delete any already stored response for the same URL. If there is an old response already stored for a particular URL, returning no-store will not prevent the client from reusing the old response. Moreover, we lose many advantages that HTTP and browser have, including the browser's back-forward cache. In modern web development that follow the agile pattern, JavaScript and CSS files are frequently updated as development progresses. Also, if a version of JavaScript and style resources that a client uses are out of sync, the display will break. A solution to the obsolete JavaScript and CSS file is service files with URLs that include a changing part based on a version number or hash value. Since the cache distinguishes resources from one another based on their URL, the cache will not be reused again if the URL changes when a resource is updated. That's all for today. Like and subscribe to the channel. See you at the next stress-free coding video. Bye.